Okay, before we start talking about medians and altitudes, we do have to review a couple of key pieces of information again. First of all, when we're dealing with triangles, we recall they have three angles, we recall they have three sides. We now need to recall the idea of what side is opposite a given angle. So if I am given angle A, this angle here, the opposite side is the side it forms when it opens up. So in this case, opposite angle A is this side here, segment BC. Okay, and then we can do the same thing for our other angles. Angle B opens up and opposite is this segment, segment AC. And finally, angle C, opposite, it opens up to segment AB. That's an important idea as we move into talking about medians or talking about altitudes. The next is a midpoint. We should have this one down after our proofs unit, but a midpoint of a segment divides the segment into two congruent segments. And then the other one is that if two segments are perpendicular, they intersect to form right angles. So those are some of our important definitions to remember from our previous units. Why are they important? Well, because our median and altitude utilize both of those. A median is a segment. It's not a line, it's not a ray, it's a segment. And the endpoints of the segment are the vertex of a triangle. So, for example, N, and the midpoint of the side opposite. Opposite N is segment IU. If I had M as the midpoint of that segment, then I could say segment NM is a median. If I look below here, it does say a fact. Every triangle has three medians. Well, that's true because it has three angles. If I have angle I as my vertex, and I go over here and say point D is a midpoint, then segment ID is a median. And the same would hold true if I start at U and I move across to, let's say, point P. If P is a midpoint, then segment PU, is a median because it connects a vertex to a midpoint. On the other side, an altitude is also a segment, not a line, not a ray. And one vertex of the triangle is an endpoint as well. For example, P. However, the opposite side is going to have my second endpoint, but it is not the midpoint necessarily. It is perpendicular to the opposite side. So this might be my midpoint, but if I drew that segment wouldn't be perpendicular. So what I need to do here is find the segment that would both go through this point or go through this vertex and be perpendicular. That would be my other point. It has no special properties, that point, to this side. All it does is make sure that that segment is perpendicular. And there are three altitudes because, again, I have three vertices. So if I start at my vertex S and I go perpendicular to the opposite side, then that would go somewhere around right here to give me a perpendicular. This point, again, has no meaning when it comes to dividing this side. It just happens to be the point where my segment is perpendicular. I could do the same thing from point N. Go perpendicular to my opposite side. That might be somewhere right around there. Again, these are all just estimates. We'll talk later about getting this as something that's more exact. We're just getting the idea as to what it is. Now, an altitude does not always have to go through the triangle. It can be drawn externally. Well, what does that mean? Well, this altitude, I think most of us would see and agree, would go to here. It would be perpendicular. But what do I do with this? There's no line I could draw inside my triangle that would be perpendicular. It doesn't exist. So what I would actually need to do is, using a straight edge, extend this side, my third side, out. Then I could draw something perpendicular. So this point is not on or in or near my triangle. But that's the point that would allow me to get the altitude from this vertex up here. So that is still an altitude even though it's not on or in my triangle. We have an external altitude there. Let's look at some algebra applications of medians and altitudes. The key here in all of these problems is going to be to read the directions carefully. You're going to need to know all of the properties of all of these segments, mid-segments, and perpendicular bisectors, and medians and altitudes, and then the last one that we'll learn about in our next video. In this case, we are told that segment AE is a median. So we have to recall median, we have to think midpoint. So if AE is a median, then E is a midpoint. That's our key, one major idea with medians. So if I want to find x and the perimeter of the triangle, the only thing I know is that E is a midpoint. So I'd set 8x minus 5 equal to 5x plus 16. Algebra would tell me that 3x is equal to 21 and x equals 7. Then to find my perimeter of my big triangle, I need to find my three sides. Well, I know that x is 7, so this is 21. I know that this is 12 plus 42. That's 54. I know that this is 35 plus 16. That's 51. And then that's 51, so this whole side must be 102. So the perimeter is 21 plus 54 plus 102. That's going to be 176. Or more accurately, 177. Okay. Now, in number 2, again focusing on the directions, the segment that's drawn in there, EJ, is an altitude. So, an altitude means perpendicular. That's all it means. It tells me nothing about these sides, it tells me nothing about these sides, it tells me nothing about these angles. I only know that these two angles are equal to 90 degrees. So 7y plus 41 equals 90 is the only equation I can set up. Algebra, subtract 41 from both sides, I get 49, I get y is 7, the measure of angle XEI, well, x to E to I is this big angle. Okay. If I plug 7 into y here, this angle's 21 degrees, this angle's 15. We can see it is not an angle bisector. If I add those, so angle addition, I get a 36-degree angle. Number 3. This is a much more important type of problem. It says that segment ZC is a median. You're going to notice that I'm going to make it look like, hey, wait a minute, that might be 90. It's not. You can never assume it's 90, especially since I'm going to oftentimes say, find x if segment ZC is a median then determine if it is also an altitude. Okay. So, example here, I know it's a median. All I know is that C is a midpoint. So I can set 10x minus 7 equal to 5x plus 3. If I subtract 5x from both sides, add 7 to both sides, I get that x is equal to 2. Okay? That's all this problem was asking. But if it had also asked if it was an altitude, I know x is 2 because I know that this is a median. To check if it's also an altitude, I'm going to plug my 2 into here. 15 times 2 plus 42 is 30 plus 42. That's 72, so this is a 72-degree angle. Well, that's not an altitude then, because if it was an altitude, that would have been a 90-degree angle. So, in summary, a median and altitude are similar in two ways. They both start at a vertex, and they both go to the opposite side. Those are some big similarities, but they're different in a very specific way. Medians bisect the opposite side, or they go to a midpoint. But altitudes are perpendicular to the opposite side, not necessarily the midpoint. Okay. The next video for today is going to discuss our last special segment for triangles, an angle bisector.